So here we have the basics of pointers, as I showed to you last lecture. We can create them like this, assign to them like this, and dereference them like this. That is, get the original value back. Now, surprisingly, or maybe not surprisingly, this is pretty hard to get straight. In fact, this is just hard in general. The difference between addresses and values is very confusing at first brush. Thousands of C coders have suffered this before. Don't be afraid to stop and think about your code. So now that I've given you that warning, let me give you another one. Pointers give you a lot of flexibility, but with that, they also come with a bit of danger. I'll show you why. So here we have this nice sample of code, right? We have this global variable *f. And so we have this first function, which say we call it from like main or something. What it does is it calls function 2, which sets f, the global variable, to be the address of this number, right? Then we come back, and then we try to print f out. Bad things will happen. As a general rule of thumb, we don't want a pointer to reference to an object which later goes out of scope. This is because once number goes out of scope, as in, like, we clearly can't reference a number here, then there's no reason for C to keep number in memory. So C could basically put whatever it wants here, or even worse, it could just mark number as out of reach memory. So what happens when we try to dereference f is most likely that C will tell us, oh, that's bad, you shouldn't be dereferencing that. It tells us that through something called a segmentation fault. What that means is that you're trying to access memory that's out of bounds for some reason or another. Now, the actual reason why, about scope, why like number here is inaccessible, but say if I had it here or like in a previous function, everything would be okay, is pretty difficult to explain until we get into some more complicated concepts. So for now, just make sure to be careful and don't do anything like this. Later on, we'll show you the solution to this problem, which uses something called dynamic memory allocation. With dynamic memory allocation, C basically knows that it should keep number in memory until you explicitly say put number somewhere or get rid of number. But for now, just be careful.